YouTube. I'm going to do a quick video here. You don't have to subscribe, you don't have to click a bell or anything. Just maybe it's useful for somebody out there that I spent a little bit of time trying to figure out something. I might save you some time. I had a little problem that I was working on where I was taking one of the new microcontrollers, to me anyway, that I started to work with is the ESP32, and I'm using it to use the touch sensor and want to know when I am touching an object and not touching an object. And then I'm actually doing some computer vision stuff with it, and I'm sending it to a Raspberry Pi to see whether it's in a frame, in a field of view, and when I release it or when I touch it. And so the timing had to be very precise between these two things. So I needed to put a timestamp on this data that was transmitted from the ESP32 to the Raspberry Pi over a Wi-Fi connection. And so it was pretty easy to find out from these two sources up here. These were really nice, very, very useful people here that obviously know a good bit of stuff on this. And but it was just in seconds. And obviously I needed it to be a lot more precise than that. And so it took me a little while to figure out how to do it in milliseconds. So that's what this little video is about. And I'm not doing it with the touch sensor. I do have a much simpler setup right here where I just have the ESP32 and I just have a simple, I think I'm on pin 19 or something like that. And I'm just going through a switch and back into ground. And when it makes it, it records the timestamp and it turns on like a little LED, the onboard LED that's on pin 2. And when it releases it, it records that timestamp. So this is what I have a program for. And it works pretty good here. So I'm running the program here, and this is the ESP32. And when I push the switch, the switch has been pushed, the LED comes on, and it gives me a timestamp value. This is a lot more information what's really necessary, but you can just see this is some of the work that I did to get it working. And so pushing it, timestamp, releasing it, timestamp. So 32.25 seconds, 33.83 seconds. Push, release, push, release, push, release. It's very, very precise, 27 to 40. So it's 13 milliseconds apart. So it's quick to see that. So I'm just going to go over quickly how I accomplished this. Maybe it's useful. Hopefully it is. So one of the things to know is and if you look up, you'll find this. And I don't know how to. I'm not good at Python. I'm not a hardcore programmer. I just kind of hack stuff together and get it to work. And so I might be using the wrong words if you know a lot about the programming aspect of it. But what I learned is there's an NTP time server. And so that's out in the world, out on the interweb. And you take your ESP32 and you make a connection to that. And then when that gets set, then that it kind of sets a local clock on your ESP32. And that timer can also be referenced to the Raspberry Pi, and so that the time will be synchronized. And so you just need to do that once, and then the ESP32 will maintain that timing signal. And then when you access that local clock, there's actually a couple of different ways that, as I understand, how that local clock is referenced. There's a structure that is a T, and I don't fully understand these structures, but one of them that I use is a structure that says time info, and when I get that and I access the local clock with this time info using the TM structure, and I can print that structure out and get the time. So it will, and so that that can print in a nice format that can be like an hour. It can, well, you can kind of see it was the day and the date and the hour and the minute and the second. And so that TM structure, when you use that, and that was when you say, okay, I'm going to get local time. So that local time has time information from the clock built into the ESP32, and the local time you can get the hour from the local time, you get the minute from the local time, you can get the seconds from the local time. It wouldn't give milliseconds. If I could, that would have solved the whole issue. But it did give me hour, minutes, and seconds as well as a day and a date. And so this variable, I think of it as a variable, or maybe it's an object, or I don't know what it's really called in real programming talk. But that time info has elements that can be accessed. You can print out everything at once, but you can also get specific elements from it. And so you can get time info dot tm. You can get the hour. You can get the minute. You can get the other stuff too. You can get the day, the date, you can get all the other stuff as well. You can get the second. But I just use these three because if I had hour, minutes, and seconds, that's good. So I got these into, I got these variables. So I separated the time info out into these separate variables. So I think I call this one the hour, and I call this one seconds. And I call this, or no, I call them minutes, of course. And then I call this one seconds. So I can pull that information out. So that was one thing. And then the other thing is that not only did you get the time info variable and have the different parts of it, but then there was another structure that once it's that's also kind of useful. So that one in the ESP32 is a structure called time val, and I don't really understand these great, but and the variable is called TV, time value, and that one has two elements. So and that is accessed when you say get instead of local time over here, if you get get time of day. Get time of day, and it goes into a variable ampersand TV. Null is the command. You'll see these commands in a second. So now that variable TV has two pieces of information. It has the seconds, and these are all referenced from some beginning of time. So the time is set, and some place I read January 1st, 1970 or something like that. But people who really know this stuff, you can read more about it. But so you can get the seconds, and that one is from if you say that's the time value dot time value underscore second gives the time in seconds, and then I don't really need that one because I can get seconds over. Now what that is, so that's different than these seconds. Okay, when you give the day and date format, it's hour, minute, seconds. So it's the seconds part here. This one is the total number of seconds from the beginning of time. So it's a big number. I think it's a 32-bit number. So it's a huge number. So it's not just, okay, I can't just grab those seconds and know what the seconds are in the day, like, when it's 12:45 and 15 seconds. But this is a huge number. And I'm sure you could do some cool math. You could do some great little, probably modular arithmetic, and do some division and pull out the seconds from there. But it's a lot easier to get the seconds from the TM seconds. The other one is the time value, and it's U seconds, which is microseconds. And that one is a 32-bit number that is the fractional part of seconds for the time from the beginning of from the epoch. So this one is the useful one. So I combine this one here with this stuff here to give me the time in milliseconds. So that's kind of how it works. Which is, once I got that working, it was not too bad. So if I come here and hide this, so now what I'm going to try to do is, so you run the two things and you get the hours times 3600 plus the minutes times 60 plus the seconds. Okay, and that's from the one structure, and then you have the number of microseconds. Now this is a bit, so it might be 1, 2, 3, 4, 5, 6. So you have to, if you divide that by 1,000, that'll give you the number of milliseconds. So so there's the number of milliseconds. Well, I still want it. Okay, I'm going to take the milliseconds. I'm going to divide that by 1,000, and then add it. Put those two things together. So when you sum those up, you'll get the time. So one of them is from the one structure. This is the TM structure, and time info is the variable. And this one is from the other structure, the time val structure. And the variable is TV, and really it's just a TV underscore U second, and this is the time value, and it's the three different ones that we were talking about earlier. So that's how I got it. If you want to see some of the code with it, it is a little bit tricky to see here, but here's some of the work on setting up the required libraries to get the time and the Wi-Fi connection, and there's my Wi-Fi. You'll never be, where I am, you'll never see it, so it's no big deal. LED pin, I'm using pin 19 as the switch. Do some logic here for switch status and current switch status. Where I'm living right now in Central Time Zone, it's 21,600 seconds of offset. So so that's that. So now the important stuff for setting up the timestamp information and getting the NTP data is in the setup. So my pin mode, the LED is pin 2 output. So so I connect to the Wi-Fi. If you've never done this with ESP32s, it's not hard. I figured it out. So if I can do it, you can do it. And then I just print out the local IP address, not necessary. But now here's the key thing. Is this this sets the time on the NTP server. Okay, so now the local clock is synchronized to that server, and I print out what time that happens at, and then disconnect from the Wi-Fi. Here's logic. Pretty okay. Don't laugh. This is how I do it. I read the switch and I check if it's not now compared to the old switch. Put a little debounce in there. And then I know the switch has been changed, and so if it's been pushed in, I turn on the LED, otherwise I turn off the LED. But after each one of those events, I have a subroutine that says, okay, print out the local time, okay? So that can give me, that's my timestamp value. So now here's the key part of that. This is the local time in milliseconds function. So the two structures, the first one is that TM structure, the first one, which has the hour, minute, second stuff in it. And this is a print Um, this is a way to print out the time info from that structure in the whole right here, Thursday, January 21st, 2021, hours, minutes, seconds. So that is, so you can get that time info, you can get it all out. And then all of those things are available, the hours, minutes, seconds, the day, the month, and all that. But I just want the seconds, the minutes, and the hours. So I pull those variables out of that structure and I just print them out so you can see them, the hours, the minutes, and the seconds. So again, pretty straightforward here, right? So at Thursday, January 21st, it's so hours is 15, the minutes is 52, the seconds is 22. So those are variables that now I'm going to use in a little bit later. Now here comes the second structure, and get time of day that has those two values from the clock. So it goes in the variable TV, and elements of that are the seconds part and the microseconds part. So and I'm going to print those out, the total seconds and the fractional seconds. So those are big numbers, okay? And so the actual time from the beginning of time on the NTP server is this number, 0.278382. So, but they have to be combined. So in terms of seconds as milliseconds, it's this 22.27. So I'm just combining these two parts next. And so the total seconds, total fractional seconds, and then here's the milliseconds part. That's going to be divided by 1,000 to add it to the seconds, and that gives me that fraction of seconds. So seconds as milliseconds is right there, and then the total time as just seconds is the hours and the minutes and the seconds. So that's the finish up there. So you can combine all those parts. The 15 hours times 3,600 seconds per hour, 52 minutes times 60, plus the 22, plus the 0.27. So there's the time in hours minute. Now that needs to be converted to a string for sending over Wi-Fi to a Raspberry Pi, and I'm not going to talk about how to do that. It worked. It was pretty cool. I was happy to figure out how to do it, but the time thing was really the killer. And so when this is running, there it is again. So hope that helps you. If it does, do something cool with it. All right.